Welcome to Stat 216. In this video, we will cover the descriptive statistics and preliminary chapter in your textbook. This is covered on pages 1 through 10, 261 through 263, 266, 324 through 327, and 330 through 331. Let's start with some basic terminology. Statistics is defined as the science of producing useful data to address a research question, analyzing the resulting data, and drawing appropriate conclusions from the data. We are going to use your book's 6-step process to investigate statistics. We will begin by asking a research question or coming up with a research hypothesis to try to learn about some aspect of the world around us. Next, we will design a study, chapters 2 and 4, and collect our data. Once we have our data in hand, we need to explore it. That means plotting the data and describing any trends we see. That's what this chapter will focus on. Once we understand our data on the surface, we will dive in deeper and analyze the data, step 4. We can do that in two ways. Significance is shorthand for a test of significance, or you may have heard this referred to as a hypothesis test. Estimation is the process of creating a confidence interval. In step 5, we'll use our analysis to formulate conclusions. What does our data say about our research question? To what group do the results apply? Generalization. Or is there a causal link? Causation. Finally, we look back at our study. Were there any flaws or hiccups during data collection? Do our conclusions lead us to any new research questions? Throughout chapters 1, 3, 5, 6, 7, and 10, we will repeat this 6-step process for new types of data, so be sure you have a handle on this flowchart before continuing. Our next term is observational unit. This is defined as the individual entities on which data are collected. Observational units are often people, but they could be animals, items, or even something more abstract like attempts or guesses. A variable is the recorded characteristics of the observational units. If you think of a survey, each question asked would be a variable. Some studies only record one variable, some 2, some 3 or more. This course will only focus on analyzing up to 2 variables at once. Variables can be either categorical or quantitative. Categorical variables put observational units into groups, where arithmetic does not make sense and there are no units. Some examples of categorical variables are sex, ethnicity, religion, and eye color. Notice each of these are words that you would record about the observational unit. Another word for a categorical variable is a qualitative variable, but in this course, to keep them separate, we're going to use the term categorical. Quantitative variables are numbers, where you can use arithmetic. You can add them, subtract them, or average them. Height, weight, distance, and time are all examples of quantitative variables. Quantitative variables should have units attached to them. But be careful, because some numbers are not quantitative. They are in fact categorical variables. An example of that is zip code. If we collected each of your zip codes, it would not make sense to find the average. Your zip code tells us where you are and places you into a group. The average zip code does not tell us anything about our class. Additionally, you can bin numbers to make them categorical. For example, age. If we recorded age as years, that would just be something quantitative. However, if we define age as either being a child, 17 years old or younger, or an adult, 18 or over, that would be a categorical variable. So be careful when a variable is a number. You need to think about how it is being used. In section 2 of the preliminaries, we learn about step 3 of the investigation process, how to explore our data. The way to summarize and visualize data depends on the type of variable or variables collected. We will start by looking at data with only one variable collected. If the variable is categorical, we can summarize a data set by just reporting the counts or frequencies in each category. Alternatively, we could also report the proportion in each category, which is just the count divided by the total. Note that a proportion is a number between 0 and 1. A bar chart is the best way to display a categorical variable. If the variable is quantitative, things get a bit more complex. The data would consist of a number for each observational unit, and summarizing a bunch of numbers can be difficult. As you might expect, one way to summarize a quantitative variable is to find the mean, also known as the average, or the median of the data. But that will only describe the center or middle. We also want to know about its variability, or how spread out the observations are. We have two measures of variability: interquartile range, or IQR for short, and standard deviation. Note that we would only ask you to estimate using a graph any one of those values, not calculate them by hand. A dot plot, histogram, or box plot could be used to display a quantitative variable. You can find examples of all types of plots in your textbook. Bar charts are on page 29, a dot plot on page 7, a histogram on page 114, and a box plot on page 326. Note, the purpose of these plots are to visualize the distribution of a variable, or the pattern of values or outcomes from our data. If we're graphing numbers, there are four aspects of the distribution that must be discussed. The center of the distribution is typically found using either the mean or the median. The variability of a distribution is typically found using either the standard deviation or the IQR. Variability is a fundamental part of statistics. Observational units vary, samples will vary, everything has variability. So we will discuss it a bit more here. You will not need to calculate standard deviation for this course, but you do need to understand what it is measuring. The average distance each value is from the mean of the data. In other words, if a data set has a standard deviation of 6 minutes, that means each observational unit's value is, on average, roughly 6 minutes away from the mean of the data. IQR simply measures the distance between the first and third quartile. A quartile means splitting the data into quarters. If you order the data values from smallest to largest, the first quartile, or Q1, is the data value which cuts off the lowest 25% of the data. The third quartile, or Q3, is the data value which cuts off the lowest 75% or highest 25% of the data. These values can be thought of as the median of the lower half, Q1, and the median of the upper half, Q3, of our data set. The IQR can be found mathematically by subtracting Q1 from Q3, or IQR equals Q3 minus Q1. It can be interpreted as the distance between the first and third quartiles, or the distance spanning the middle 50% of the data. 75th percentile minus 25th percentile gives us the middle 50% of the data. An example data set is provided to show the median, Q1, Q3, and IQR, and how each of these values would be calculated. The last two aspects of a distribution of a quantitative variable to discuss are the shape of the distribution and if any unusual observations exist. When we're discussing the shape of the distribution, we want to answer the questions: is the distribution symmetric, mound-shaped? Are there several peaks or clusters? This will be discussed in more detail in the next slide. Unusual observations are sometimes called outliers. Are there any values that are markedly different from the overall pattern? Are there any unusual features in the plot? The most important aspect of shape is whether the distribution is symmetric, as seen in the middle of the three plots, or skewed, the first picture and the last picture. When a distribution is skewed, you must decide in which direction. The direction of skew will be the longer tail, so the first plot is left skewed, while the last plot is right skewed. Unusual observations are often called outliers, or data values that do not match the pattern of the majority of the data. The 1.5 IQR rule is typically used to determine if a value is an outlier. Any data value outside the range of Q1 minus 1.5 times your IQR, or Q3 plus 1.5 times your IQR, is considered an outlier. Using the same data set seen previously, no outliers are identified. There are two measures of center, mean and median, and two measures of spread, IQR and standard deviation. So when should each be used? It depends on the shape of the distribution and whether any outliers exist or not. A summary measure of a data set is said to be resistant if it changes only minimally when an outlier is removed from the data. The median is a resistant measure of center. It does not depend on the individual values at the ends of the data, just the value or two values in the middle. IQR is a resistant measure of spread. It does not depend on the individual values at the ends of the data, just the value of the two values in the middle of the lower half and in the middle of the upper half of data. For this reason, use median and IQR to describe a distribution that is skewed either direction or has outliers. If the distribution is symmetric with no outliers, mean and standard deviation are typically used. What if I've collected more than one variable in my study? In this class, we'll look at lots of examples where we collect two variables in the study and analyze them at the same time. If both variables are categorical, then we would summarize the data by finding the proportion of successes within each group. Then we can convert those two proportions into one number, either through an additive manipulation, finding the difference between the two proportions, or a multiplicative manipulation, finding the ratio of the two proportions. We would visualize this type of data using a segmented bar graph, seen on page 263, where we would have a bar for each group, and the segments would correspond to the proportion of successes or the proportion of failures within each group. If, in our two-variable scenario, one was categorical and one was quantitative, we would find the mean in each group. In other words, find the mean of the quantitative variable for each level of the categorical variable. Again, we could find the ratio of the means, but much more commonly, we'll look at the difference between the two values. We can visualize one categorical and one quantitative variable using stacked box plots, where we have a box plot displaying the quantitative variable for each level of the categorical one. What about two quantitative variables? We'll get to this at the end of the course.